Hi. Today we're going to be doing lesson 13, session 1. And this will be in our Ready Math workbook. We'll be working on pages 249 through 252. Today we're going to be learning different strategies we can use to subtract fractions. The good news is that subtracting fractions is almost exactly as adding fractions. The steps are the same. Everything, the process is pretty much the same. The only thing that's different is that instead of adding the fractions together, we're going to be subtracting. That's about it. I think we can handle that. So let's go ahead and go to our Ready Math workbook to page 249. Okay, so we're on page 249, subtracting fractions. It says, in the previous lesson, you learned about adding fractions. Now you will learn about subtracting fractions. Use what you know to try and solve the problem below. So let's go ahead and read the problem. The problem says, Paul has a 3/4 inch long bolt. This is a bolt. It's like a screw, but it's called a bolt because it has a bolt head instead of a screw head. He buys a bolt that is 1/8 of an inch longer and a bolt that is 1/8 of an inch shorter. So he has a bolt and then he buys two more bolts. One is 1/8 of an inch longer, one is 1/8 of an inch shorter than the original bolt. What are the lengths of the two bolts he buys? So first of all, what in the world is this problem talking about? This problem is talking about bolts. And if you don't know, this here is a bolt. Again, it's like a screw. You use it to put stuff together. Okay, so we're talking about bolts. Now, what is it that we're trying to find out? We're trying to find out what are the lengths of the two bolts that he buys, because we know that he's going to buy two more bolts. So the important information that we need to have is that the original bolt is 3/4 of an inch long, and then he buys one that is 1/8 of an inch longer, and he also buys one that is 1/8 of an inch shorter. So we need to find out the length of two different bolts. So if you'd like to try this on your own, which I think you totally could do it, then go ahead and pause the video, solve the problem, and then come back to see if you solved it the same way I did. If you're not quite sure what to do, you are welcome to just stay on with me and go ahead and go through the process of learning how to solve this problem with me. Okay. So if it were me, what I would do first is I'm going to draw a picture today. That's how I'm going to use almost like a bar graph is what I'm going to use today. So I'm going to draw this bar graph. Now, we know that the bolt is 3/4 of an inch long, this bolt. So we need to break our bar graph into fourths. And then we're going to shade in how many fourths? We're going to shade in 3/4 because we have the bolt is 3/4 long. So here is our bolt. And this is a 3/4 long bolt. Now, he buys two more bolts. I don't know why. He just decided he needed two more bolts. So he bought one bolt that was longer and one bolt that was shorter. And the one that was longer by 1/8 of an inch, and the one that was shorter by 1/8 of an inch. But if I'm trying to compare and I want to draw the bolt, so I'm going to draw a bolt that's going to be longer, and then I'm going to draw a bolt that's going to be shorter. So this one is going to be 1/8 longer, and this one is going to be 1/8 shorter. Now, I need to make, this is going to be broken into eighths because we're going to be looking at eighths. And this one I'm also going to break into eighths because we know that we're dealing with eighths. So I've broken each of these holes into 8 parts. Okay? Now, The tricky part is that I can't really compare 3/4 and 1/8. So I need to find out how many eighths is 3/4. So I need to make an equivalent fraction that turns this into eighths. So what do I multiply 4 by to get 8? That's right, I multiply it by 2. And then whatever I multiply my denominator by, I'm also going to multiply my numerator by. So 3 times 2 is 6. So 3/4 is the same as 6/8. So what I can do is I can break my whole up into eighths. And then look at that. Let's make sure we've got 6/8. 1, 2, 3, 4, 5, 6. Oh, good. Okay, so we're good. So now we have our bolt that is 3/4 of an inch long, or 6/8. And now we're going to draw a bolt that is 1/8 of an inch longer. So if we had 6/8 and we wanted to draw it 1/8 of an inch longer, that means we're going to add 1/8 of an inch to it. So if I'm going to highlight that, then I'm going to highlight the same 6/8 because that's the same size. And then I'm going to highlight 1/8 of an inch longer. And now let's see how many we have all together. 1, 2, 3, 4, 5, 6, 7. 7/8. So the 1/8 of an inch longer is 7/8 of an inch. Now, if I want to do one that is 1/8 of an inch shorter, that's going to be the same as, we'll start with our 6/8. We're just going to start with 6/8. This time we're going to subtract 1/8 from 6/8. So if we have 6/8, which is here, and we take 1 away, then we're going to highlight 1 less than 6, which takes us all the way to there. So let's go ahead and count and see how many we have now. 1, 2, 3, 4, 5. 5/8. So the bolt that is 1/8 of an inch longer is 7/8. So 1/8 longer is 7/8 of an inch, and the 1/8 shorter is 5/8 of an inch long. So now we have a picture that shows what we did. We also showed that we found an equivalent fraction for 3/4 to get 6/8. And then we showed here we added fractions, and here we subtracted using, we had to make sure that we had common denominators. So great job. If you did that on your own, did you solve it the same way I did, or did you do it a different way? And did you come up with the same answer? All right, let's go ahead and go to page 250. All right, so looking back, it says, explain how to find the lengths of the 2 bolts Paul buys. So let me focus that for you. All right, so it says, first, you need a common denominator. Oops, there we go. Let's see if that is going to autofocus. Oh, and there we go. First, you need a common denominator. So we found out that 3/4 was equal to 6/8. Then we could just add and subtract the eighths from the 6/8. I drew the picture, but we could have done it without the picture just by turning this 3/4 into 6/8, and then 6/8 plus 1/8 was 7/8, and 6/8 minus 1/8 equals 5/8. So some of you may have just done that and totally not even worried about drawing the picture, which is 100% okay. Now for number 2, it says, let's go ahead. All right, there we go. Just like with adding fractions, you must find a common denominator to subtract fractions with unlike denominators, such as 3/4 minus 1/3. Write the first 4 multiples of each denominator. Then circle the common multiple to find a common denominator. So we're going to start with our multiples of 4. Remember, we always start with 4 times 1, which is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. Then we're going to move to our multiples of 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. Then we're going to look and see if we have any common multiples. So our common multiple is 12. So we know that we need to take 3/4 and 1/3, and we need to use a new denominator of 12 and then make equivalent fractions. So then it says here, complete the models and equations to show the equivalent fractions for 3/4 and 1/3 using the common multiple as the common denominator. So here we see that we started with 3/4. This whole bar is broken into 4 sections because our denominator says there are 4 parts. 1, 2, 3, 4. Our numerator tells us how many of those parts we're going to shade in. So we're shading in 1, 2, 3. So this bar model shows us 3/4. This bar model shows us 1/3 because we have the bar is broken into 3 sections and we've shaded in one of those sections. Now, to find a common denominator, we're going to go ahead and shade in the same amount on the bar below each of these sections. So these bars, since they are drawn evenly, we know that we can simply count the number of parts and find our new numerator. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now remember that we also learned that if we are making equivalent fractions, we can find out how many times we multiply 4 to get 12, which would be times 3. And then we can also multiply the numerator by the same amount to find out what the new numerator is. So if you're not drawing the bar graph, you can still find an equivalent fraction without drawing the bar graph if necessary. And then here, the equivalent number of twelfths to 1/3 is 1, 2, 3, 4 twelfths. Or 3 times 4 is 12, 1 times 4 is 4. Hopefully you guys can see that. Okay. Now for letter C, it says use the equivalent fractions to subtract. So now we have our new, so 3/4, we found the equivalent fraction of 9/12. And then 1/3, the equivalent fraction was 4/12. Then we can subtract. Now remember, we keep the same denominator. We do not subtract the denominator. So now 9 minus 4 equals 5. So then the answer of what is 3/4 minus 1/3, our difference is 5/12. Now I want you to tell me, how is subtracting fractions like adding fractions? What is it? So I'm going to say adding and subtracting fractions are alike because, and then I want you to tell me 1 or 2 ways that adding and subtracting fractions are alike. Go ahead and pause it, do that now, and then when you're ready, we're going to move on to page 251 and fill out our graphic organizer. So our vocabulary word in math today is equivalent fractions. So what are equivalent fractions in our own words? Equivalent fractions are 2 fractions that have the same value. Both fractions name the same part of a whole and the same point on a number line. Now, a way that we can show equivalent fractions is here I've drawn 2 pie chart or pie I would say two pies. And this pie is broken into two parts. So the denominator is 2, and 1 has been shaded in. So we have 1/2. Half of this circle is shaded in. Now, in this illustration, half of the circle is still shaded in, but this time it's broken into 8 parts. And I colored in 1, 2, 3, 4 of those 8 parts. And so 1/2 is equivalent or equal to 4/8. They both name the same part of a whole. Even though they are not the same fraction, they are equivalent. So here are some examples of equivalent fractions. 1/3 is equivalent to 2/6. 1/3 is also equivalent to 3/9, and 1/3 is also equivalent to 4/12. In all of these, if I drew a picture, the pictures, they would be in smaller pieces. I'll just go ahead and draw the picture. So this would be, so if I'm going to have 1/3, I'm going to shade in just this top part here, okay? So that's going to be the same for all of these 1/3. 2/6 is going to be the same size circle, and I'm gonna color in 2 of the 6 pieces. For 3/9, same circle, but now I've broken this into 9 parts, and I'm gonna color in 1, 2, 3. And then the third circle, as you can see, I'm gonna color in 4/12. And as you can see, 1, 2, there we go. 1, 2, 3, 4. It gets a little harder when you're drawing a lot and on the fly. And then I'm going to color in 1, 2, 3, 4. Now this one is not drawn completely to scale, but you can see that no matter what the fractional part was, it always colored in the same amount of each of those circles. Imagine that those were all the same size. Mrs. McGuire's coloring skills are not too fabulous today. Now here are some non-examples of equivalent fractions. 1/2 is not equal to 5/8. 1/7 is not equal to 22/23, and 3/5 is not equal to 2/7. Those are just two fractions. All of those are just naming different fractions, but they are not equivalent. You're going to go ahead and finish numbers 2, 3, and 4 on your own. And then you, as always, if you have any questions, you can always email your teacher. Otherwise, I will see you next time.